Alright, so welcome to another video. In this video, we are going to look at how we can find the turning point, the line of symmetry, and then the roots or the zeros of a particular function. Right, so this is the function we have right here. F of x equals 1 minus 2x minus s squared, right? Right, so this is what we have, and we want to find the turning point, the line of symmetry, and the roots, which of course is the same as the line, the zeros, of course. So we want to show that for all values of x, the function f of x is less than or equal to 3 on 2. So indirectly, we have been given the value of q. Right, so here, let's look at how we can find this. For all values of x, they are saying that f of x is less than or equal to 3 on 2. So let's go. So f of x is equal to 1 minus 2x minus 2s squared. Right, so we want to find the turning point, the line of symmetry, and the zeros. Of course, we know that we have to apply what we call the completion of square method, right? Then we can go and apply the quadratic formula as well to find the roots, right? So here, let's begin. We know that this f of x is equal to negative 2x squared minus 2x plus 1 over here. But what we said before you can apply the completing of square method, you have to make sure that the coefficient of s squared is unity or 1. So here you have f of x equals negative 2 out, open brackets, s squared plus x minus half, right? We factored minus 2 out. So minus 2 out, you're going to have this right here. So now we can apply what we called the completing of squares at this point. So what do? We look for the coefficient of x, right? And the coefficient of x right here is 1, right? So what do? We multiply it by half. So we multiply the coefficient of x by 1, and we are going to have half x minus half right here. What did we say? The result we have, we square the result and then we add and subtract to the equation. So here we have negative 2 into s squared plus half x plus half all squared minus half all squared minus half. Right, so we have that right here. So here we can go ahead and say that f of x is equal to minus 2 into s squared plus half x plus half all squared minus 1 on 4, expanding that, minus 1 on 2, right? So we have f of x equals minus 2 into these three terms, you combine it and make it a square, perfect square. So here we have x plus half all squared, then minus 1 on 4 minus half. What are you going to have? You have, of course, minus 3 on 4, right? So that here we have minus 3 on 4, right? So once we have this, then we can go ahead and multiply through by the coefficient over there. So here we say that f of x is equal to minus 2 into x plus half all squared times, okay, minus 2 times minus 3 on 4, right? So we have f of x is equal to minus 2 into x plus half all squared. So here, you know that minus 2 times minus 3 on 4 is going to give us plus 3 on 2. So here, we have plus 3 on 2. So here, looking at the question, it said that we should show that f of x, for all values of f of x, is less than or equal to 3 on 2. And that is what we have proven over here. Very interesting. I hope you are enjoying the lesson. Don't forget to press on the notification bell, subscribe, and I will give you more content. So let's proceed from here. So we have shown the first part. Now let's find the equation of the axis of symmetry. The equation of the axis of symmetry and the turning point, right? So here, if you want to find the equation of the axis of symmetry, what we do is that you set this right here in the bracket to 0. So the equation of the axis of symmetry, right, is s plus half equals 0. This implies that x is equal to minus half, right? So our equation of axis of symmetry is equal to minus half. Now, we have been able to find the equation of axis of symmetry. That is very simple. We have right here. The next one is we have to find the turning point. The turning point. So the turning point becomes the axis of symmetry, which is the equation of the axis of symmetry, and then this point, the value of Q. So we combine the value of Q, which is equal to 3 on 2, and the value of P, which is equal to minus half. And then we have the turning point. The turning points P and Q. That is equal to 3 on 2 and minus half. 3 on 2 and minus half. And that becomes the turning point. So this, of course, will have a maximum turning point. A maximum turning point. Because our A, the coefficient over here, is less than A, 0. So we will have a maximum turning point. You will have a maximum turning point. So since our A is less than 0, we have a maximum turning point, and that is the maximum turning point, and that is minus half and 3 on 2. Minus half and 3 on 2. Right, so we have our maximum turning point. Now we are interested in finding the roots or the zeros, right? So in finding the zeros, all you do is that you take this and equate it to 0, right? You take this equation and equate it to 0. So here the zeros of the function is obtained by equating f of x to 0, right? So when we do that, then we're going to have 0 equals negative 2 into s plus half all squared plus 3 on 2, right? We are interested in x, so let's bring this here and maintain this. So we have 2 into x plus half all squared plus, that should be equal to 3 on 2, right? We are interested in x, so let's go away with these 2 here, right? So we have x plus half all squared is equal to 3 on 4, right? So once we have this, then we take square root on both sides, and that is going to be plus or minus square root. So we have plus or minus square root of this, right? And this takes of this, so we have x plus half is equal to plus or minus square root of 3 on 4, right? And that we have the values of x equals plus or minus square root of 3 on 4, right? You know that s will be equal to minus half plus or minus square root of 3 on 2, right? So we can easily say that our value of x, x1, is equal to minus half plus square root of 3 on 2, or our s2 is equal to minus half minus square root of 3 on 2, right? And this, of course, can be simplified, right? Can be simplified. Half plus square root of 2 can be simplified. So you can, of course, simplify it and get the exact, whether it's going to be decimals or what. You can leave it this way anyway. So these are the zeros or the roots of the equation. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to press on the notification bell, subscribe, like, and share with your friends, and I'll give you more content. Bye-bye.